Welcome, students. Today we're going to look at multiplying and dividing integers. We're going to talk about what multiplication and division are. We're going to look at the algorithms, or the ways that we go about performing multiplication and division. And we're also going to talk about the rules for when we have negative numbers. So first, let's talk about multiplication. When you look in a textbook to see what multiplication actually is, it's usually defined as repeated addition. So if we look, for example, at 3 times 5, what that really means is that the number 5 gets added 3 times. We've got 3 times the number 5. And when we add those together, 5 plus 5 plus 5 equals 15. So 3 times 5 is 15. If we were to switch the order of those, 5 times 3, that would be the number 3 added 5 times. And when we take 3 plus 3 plus 3 plus 3 plus 3, we also get 15. And this isn't a coincidence. This will happen no matter which numbers you're multiplying. The order of multiplication, when we're multiplying two numbers, doesn't matter. We call that the commutative property of multiplication. It's just like when we're adding two numbers, the order doesn't matter. Now what I want to do is I want to use this definition to explore what happens when we have negative numbers. Let's look at 3 times negative 5. Here we have a positive times a negative. What this means is the number negative 5 being added 3 times. So this is negative 5 plus negative 5 plus negative 5. If we take the first two and add them, negative 5 plus negative 5 gives us negative 10. And if we add another negative 5, that gives us negative 15. So here we can see that if we have a positive number times a negative number, we end up with a negative result. It's interesting, and it's a different rule than we had with addition and subtraction. Now let's take a look at a couple more. If we were to look at negative 3 times 5, for example, we know that the order doesn't matter. So this would be the same as adding negative 3 5 times. Negative 3 plus negative 3 plus negative 3 plus negative 3 plus negative 3. And if we add these up, negative 3 plus negative 3 is negative 6. Then we add another negative 9, another negative 12, another negative 15. And so we end up with negative 15 again. So whether it's a positive times a negative or a negative times a positive, we both end up with a negative answer. And then the last one is a little bit harder to show. If we take a negative times a negative, like negative 3 times negative 5, it's more complicated to explain why this works, because when you're adding something a negative number of times, it's like you're subtracting it. And what happens when we subtract a negative? We've seen that before. It's adding a positive. So effectively what happens is those negatives cancel out and we end up with a positive answer. This is more complicated to demonstrate, so I'm just going to tell you a negative times a negative is a positive. So we've seen several situations here, and we want to have a rule that tells us what to do in any situation. And the simplest way to write the rule is as follows. When we're multiplying, if two numbers have the same sign, the answer is going to be positive. And if they have different signs, the answer will be negative. This matches all of the examples that we've seen so far, and we can use this rule to look at more complicated situations a little bit more quickly. Really quick, notice that this rule is different than the rule for adding and subtracting with negatives. When we were adding and subtracting, if they had the same sign, we took the sum. If they had different signs, we took the difference, and then we took the sign from the larger number for the answer. This is a completely different set of rules, and so it's important that you understand them and that you're able to apply them. Now, usually we don't write out repeated multiplication. There are other ways that we multiply, and there's two pretty common ways that we do that. One, when we've got a one-digit number times a one-digit number, like 8 times 7, typically we spend a bit of time in elementary school learning our times tables, and so we have those memorized. So 8 times 7 is 56, back from elementary school. If you don't remember the times tables, you could take 8 plus 8 plus 8 plus 8 plus 8 plus 8 plus 8. That would take quite a bit of time. So instead, it's better to just memorize those times tables. So if you don't remember them, you can Google times table. I'm sure you'll find hundreds of them. You can print one out, put it up on your wall, look at it every once in a while, and try and remember the ones that you've forgotten. Even if you're a little bit shaky, I'm pretty sure you'll find that there's a lot of them that you remember. Now with larger numbers, when we don't have them memorized, we have to go through a process. Let's look at 12 times 16. I don't know off the top of my head what 12 times 16 is, so you probably don't either. And in a situation like this, we set up a multiplication problem, and it looks similar to the addition problems we did before, except we have a multiplication symbol instead of an addition symbol. So here we've got 12 times 16, and because multiplication is different than addition, we have a different process. Let's go through that process. We start with the lower right-hand number, in this case 6, and we're going to multiply it by all of the digits in the first row. So 6 times 2 gives us 12. We put the 2 down there and carry the 1. And then we do 6 times 1, which gives us 6, and we add the 1 we carried to get 7. Now that we're done with the 6, we're going to do the same thing with this 1, but we need to bring down a 0 as a placeholder. That's because this 1 is in the tens place, so when we look at our answer down here, we've got to start in the tens place, not the ones place. And again, we're going to multiply this by each of the digits above. 1 times 2 is going to give us 2. And then 1 times 1 gives us 1. We're not going to use this 1 up here because we carried that over in a previous step, so that doesn't apply here. And once we've finished all of the digits in the second row, we can add the results that we have below. 2 plus 0 is 2. 7 plus 2 is 9. We bring down the 1, and we end up with 192 as our answer. This is the multiplication algorithm, and we can do it for numbers with significantly larger digits. My recommendation for you is that if one number has more digits than the other, you put that number first. We want to minimize the number of digits down here to minimize the number of rows that we have below. It's going to work either way, but sometimes it's good to make a decision that gives you a little bit less work. Now, what would we have done if instead of 12 times 16, it was 12 times negative 16? Well, in this case, we know that when we're multiplying and they have different signs, our answer is going to be negative. So a positive times a negative is going to be a negative. So we can figure that out right away. And then when we do the multiplication, we set it up just like before, but we don't put the negative in the actual multiplication problem. We just do it out. Now, I'm not going to go through this process because we just did it. We knew that we got 192. So in this case, our answer will be negative 192. And lastly, if we had negative 12 times negative 16, we know that a negative times a negative is a positive, and so in this case, it would be positive 192. In the next video, we're going to go over division, but below you can see a link to several videos that go through some multiplication examples and then also some division examples. So if you feel like you need more practice with any of this, you can click on this link and watch any of those videos.